Welcome back to NPTEL online certification course on novel drug delivery systems. I am Dr. Satish Devanapelli, working as assistant professor at Department of Pharmaceutical Sciences and Technology, Institute of Chemical Technology, Mumbai. We have started introduction to novel drug delivery systems. In that, in our previous class, we have discussed the polymers used in the drug delivery systems. In our previous class, we have discussed on the introduction on the polymers, and then we have discussed the various classification based on their properties we have discussed. And then further we have seen the what is the biodegradation and how polymers undergo the biodegradation, and further we have seen various drug delivery applications as well as non-drug delivery applications, and after that we have learned the advantages and the limitations of polymers which are used in various drug delivery applications. So, today we are going to learn on the selection of polymers in the drug delivery systems. So, first we are going to start on the what are the roles of polymers in drug delivery systems. Then we will see the criteria for the selection of the polymers in drug delivery systems. So, yes, in last class also we have discussed on the polymers, what are the polymers, and we have seen the nature of polymers and the properties, and also we have seen the various drug delivery systems which we use polymers. As we know that polymers are the macromolecules and which are the collection of the monomers, and yes, we know in our daily life we use lot of polymer based materials in case of packaging and food application and other non pharmaceutical applications we use polymers. Now, we know that even in the pharma, polymers are the backbone for the pharmaceutical industry. So, we can also make drug delivery systems because of their unique surface and the bulk properties which the enhanced and the utilization of the polymers in the drug delivery systems. So, that is why we use these polymer based drug delivery systems in pharmacy in various applications. So, here we will see the amalgamation of polymer science with the pharmaceutical science. We will take various polymers and our drugs, our carriers, therapeutic agents and the active molecules will mix it or will unite them and will create one delivery systems, which speaks about the novelty because of their physical state will change and their shape, size, surface also will change. So, there is a huge scope by playing with the polymer materials we can design and develop the novel drug delivery systems. So, these are the various roles of polymers in the drug delivery systems. By using the polymers, we can control the drug release from the formulations, and also we can protect the various active molecules throughout the various routes. In that, we can see oral and injectable routes are very commonly used delivery routes, and here we can also protect all type of enzymatical, pH degradation in the body. And also we can improve the loading when you compare with the conventional formulations. So, by using of polymers, we can enhance the drug loading, and with that we can increase the bioavailability of the active molecules in the body. And with these polymers, by using various stimuli responsive polymers like pH sensitive, temperature sensitive, enzymatical responsive polymers, we can deliver the molecules, active ingredients into the target site. Also, we use polymers as an stabilizers and surfactants, and then not only that, by using these polymers in novel drug delivery systems, we can mask the bitter taste of the various active ingredients. So, these are the various roles of polymers in the drug delivery systems. So, here we are going to see the criteria for the selection of the polymers in drug delivery systems. In our previous class, we learned what are the ideal properties of the drug delivery systems. There we have discussed the nature of the polymers, and we have seen the biodegradability, and also we have seen their mucoadhesive properties of the polymers which we can use for the polymer nano drug delivery systems. So, here we are going to see some of the properties which are very important while selecting the polymers in drug delivery systems. Now, here you can see the first one is the bulk properties, which are very important when you want to go for polymer as a carrier for the drug delivery systems. So, these properties are very important while developing any type of the control release systems. So, because the molecular weight and the adhesion properties, solubility of the polymer in the body, which will influence the release mechanisms. So, when you use polymers, the release mechanism happens through various process. So, first one is diffusion, and the second one is dissolution control release systems, and this release happen through the physical degradation of the polymer. And not only that, this release also happens because of the swelling of the polymers. And this bulk property is also very important for the action at the target site. So, bulk properties are very important for the selection of the polymers. So, while designing of the new drug delivery systems with the polymers, and if you are looking for targeting for some mucosal drug delivery systems, in such cases we need to identify which is the right polymer we can use it as a mucoadhesive polymer. So, the second point we need to consider for biological applications and as a drug delivery system, we need to see the bioadhesiveness of that polymer, which is very essential for various mucous drug delivery systems. For example, ocular and nasal drug delivery systems. In our previous class also, we have learned the various polymers which are biodegradable as well as mucoadhesive polymers. So, this polymer, these mucoadhesive polymers will adhere to the mucous membrane on the various organs. So, with that we can increase or retain the permeability, or we can retain the time to the contact to the biological tissues. So, with that we can improve the retention time of the drug delivery systems in the body. Now, the third point is structural properties of the matrix. So, here its micromorphology and pore size are very important with respect to mass transfer of water into the polymers and drugs from the out of the polymer is very, very important. So, yes, this will definitely, that properties will influence the release mechanism of the novel drug delivery systems. So, while designing, we need to consider the bulk properties, bioadhesiveness and the structural properties of the matrix. So, in further, if you go and see the classification of the polymers, so this can be classified based on their responsive mechanisms. So, here we can see there are the various properties or unique characteristics which polymer has. So, by responding with the internal or external stimuli, so the polymer will change its behavior. It will alter from solubility phase to insoluble phase and vice versa. Sometimes when you apply some stimuli or some external energy, so your system will convert from solution to gel. In other cases, if you decrease or increase the temperature, your gel will convert into the solution phase. So, these are called as the stimuli responsive systems. So, various stimuli systems are available which are temperature, light, pH, electric field, ultrasound, enzyme and oxidation and reductions, which can be classified into two ways. One is internal stimuli which happen in the body, and the external we need to apply some external energy, so that will convert into the responsive systems. So, these are the various examples like poloxamer, polyacrylamide, polymethacrylic acid, polymethacrylic acid, polythiophene, ethyl vinyl acetate, chitosan and other polymers which undergo the various stimuli responsive mechanism. So, here we will see one by one. So, first we are going to discuss on the temperature responsive polymers. As we discussed in our previous slide, so these polymers undergo various physical changes in presence of the temperature. So, any temperature alteration happens that leads to the change in their physical property. So, that means there you will see the phase transition in the polymer. So, if you give one dosage form or any type of dosage form, when you apply temperature, your polymer will respond to the temperature and then it will undergo the physical change, and that is very, very important for the targeting, and also that is very, very important for the release. That is also very, very important to reach to the right place. So, here these responses in the temperature responsive polymers can be classified into two categories. There are the polymers which will soluble in water at the lower temperature, which are called as lower critical solution temperature responsive polymers. But when you increase the temperature above that lower temperature, your soluble polymer in the water, it will undergo into the precipitation, that will become to insoluble or it will form precipitation, which is called as LCST responsive polymers. So, when you apply low temperature, your polymer will be in the soluble state. Whenever you want to convert your solution to the insoluble or precipitate format, so you can apply the temperature more than that LCST and then it will convert into the insoluble precipitate format. And there are the other category of the polymers which are called as upper critical solution temperature responsive polymers. So, they are soluble at high temperature, and when you decrease the temperature they will become insoluble and they will precipitate, which are called as UCST responsive polymers. So, upper critical solution temperature. At high temperature polymers are soluble in the medium. So, these are the examples of the temperature responsive: poly N acrylamides, polaxomer, polyvinyl caprolactam, and the chitosanes, which are best example for the temperature responsive polymers. Now, here we will see the pH responsive polymers. So, here as we know that, so when you want to respond to the pH, your material or your polymer should take or should provide the protons. So, these pH responsive polymers are the polyelectrolytes, which are weakly basic or acidic in nature, and they will receive or liberate the protons in reaction to the variation in the pH of the surroundings. So, when you change from one pH to other pH, these polymers either they will receive or they will donate the protons, and based on that they will change their physical properties. So, here polymers containing acidic and basic groups, which are carboxyl, pyridine, sulfonic, phosphate and tertiary amines are referred to the pH sensitive polymers. So, when any polymer which contains such groups which will respond to the pH and their properties will change on based on the pH of the surrounding medium. So, here are the few examples: chitosan, polyhistidine, poly-L-glutamic acid and the polyaspartic acid. So, these are the various polymeric materials. When you see any change in the pH, they form self assembles which may convert into the micelles, and it will undergo the swelling, and which may undergo various wetting surface and non-wetting surface process, and it may form gels. So, the pH is important parameter while converting of the polymers into the responsive polymers. So, the second system is pH responsive polymers. And now we will see the third one is the glucose responsive polymers. Now, we use such polymers for the treatment of the diabetes. So, there the glucose level will increase in the body. So, such cases to treat the diabetes, we need to use such polymers. So, these polymers will respond to the concentration of the glucose presented in the body. Once it is responded, it will alter their properties, it undergo the swelling, or it will release the drug from their formulation. So, here the common strategies we use here is we can use either glucose oxidase and phenyl boronic acid, concanavalin as a glucose response system. These need to be covalently or non-covalently, we need to conjugate with the polymers or other materials. So, after conjugation, if you convert that into the delivery systems, when you apply into the body, when the concentration of glucose will increase and this system will respond with that glucose and it will swells or it will release the drug from the various mechanisms, and you will see here after response with the glucose, you will see the release of insulin from the delivery systems. So, these are, with this we can make a regulated or controlled systems with the glucose responsive polymers. Here also you can see there is a one more responsive system. Here is insulin is encapsulated and it is conjugated when it is responded with the glucose, and that complex is reversibly coming out from the system, and then that will release the drug. For more information you can see here, these are the two references, and the fourth one is photoresponsive polymers. So, here it is also known as light sensitive polymers which will respond to the light, either NIR, UV irradiation will induce the response of the polymer. So, here when it is response, it will change its solubility and it will change its viscosity and also the color, which very important for the various biomedical applications. So, this change is triggered by the light sensitive groups which are incorporated in the polymer structures, which may undergo reversible or irreversible transformation upon the light irradiation. So, these are the few examples: azobenzene, spiropyran, which are reversibly involved in the transformation upon the irradiation, and the O-nitrobenzyl, which will show the irreversible change with the polymers. So, such type of molecules we can include or we can conjugate with the polymers which will undergo the various photoresponsive systems. Here now you can see one carrier system which is respond to the light irradiation. Now, we will see there is a change after the stimuli. So, such stimuli are very important for active targeting into the various diseases, especially in case of cancer we can actively target by using the photoresponsive nanocarrier systems. In this we can also load various types of the anti-cancer molecules, so which will work as a detection or you can say diagnosis, and which is same system will work as a therapeutic application, which is called as theranosis, therapy and the diagnosis. So, with the one system we can use multiple applications. And the fifth one, enzyme responsive polymers. We know the polymers will respond to the various enzymes through in vitro and some in vivo mechanisms. So, these materials are designed to interact with the biological environments which are often used in the biomedical applications, which are drug delivery and the diagnostics applications. So, when it respond with that enzymes, it will alter their properties and they will alter their structure. So, this happened because of the catalytic action of this enzyme. These can involve in the enzyme mediated degradation, and with that stimuli they will change into self assembled structures and it will alter in their physical properties like swelling and shrinking. So, now here you can see these are the various examples which we can use it for the enzyme responsive polymers. Here is the one example is chitosan and alginate, dextran, polyethylene glycol and polyethylene oxide. Now, when you develop any system with the chitosan and when we convert into any drug delivery systems, after application the lysozymes which are present in the body which will respond and that will give the stimuli to that carrier systems, and you can see consider it is an hydrogel here which is responding with the lysozyme. Now, you will see it undergo the various physical changes and with the lysozyme enzyme trigger will help in the degradation as well as it will release the drug from the hydrogels. So, here you can use various types of the pharmaceutically active ingredients based on the site targeting. We can use such systems, we can make the nanocarriers and the hydrogels which will respond to the enzymes. With this we can target the various types of the active systems, and not only that it will help for the control release also. So, with this I am going to stop today's lecture. In our upcoming classes we are going to learn the various types of the drug delivery systems and we are going to focus specifically on the various types of the polymers used in the drug delivery systems. Thank you so much.